Hello and welcome to another video on my channel. In this video we are going to continue our discussion on operator overloading in Java. So if you recall, we create a vector 2D class to represent vector 2D objects in the 2D space, and each vector object has two real components, x value and y value. And we implemented the operator overloading for adding two vectors, subtracting two vectors, negating two vectors. But if you recall, each time we want to create a vector, we need to use the constructor, right? We decided not to use the value of method because we're not assigning the value of a primitive to an object of type vector, right? So each time the user wants to create a new object, a new vector, it has to go through the constructor, right? But if you are familiar with the vector math, in the way we write the vectors in mathematics is that for any vector space, 2D, 3D or whatever, we define a basis which has unit vectors, right? So in our 2D space we have two unit vectors, one in the x direction and one in the y direction, right? And we call them ij or x hat, y hat. Typically hat, when we say u hat, it means u divided by the magnitude of u, right? This is just a vector that represents the direction. Direction, it has the magnitude of this hat vector, or the unit vector is 1, but it represents the direction. And for a 2D space we need two orthogonal directions to be able to create a basis for that vector space. And in this space we have x hat and y hat. X points in the x direction, its y component is 0, and y hat points in the y direction, it's the x component is 0, and they both have a unit magnitude, so their magnitude is 1, so they are called unit vectors, right? But then using the power of our operator overloading, we can actually implement exactly if we want to create an arbitrary vector u with components a and b, okay, in mathematics we just say a times x hat, the unit vector in the x direction, b times y hat, the unit vector in the y direction, right? But using the operator overloading concept, we can exactly implement this kind of creating a vector in Java as well. And the way we're going to do it, we're going to define two constant vectors, x hat and y hat, and they're going to be a static final vector 2D, okay? So static final, these are constant vectors, constant objects. And then when we take two real numbers a, b, and write an expression such as a times x hat plus b times y hat, what happens here is that because both the plus operator and the times operator are overloaded, Java has no problem understanding this language and creating a vector u with the component a and b. So again, this shows the power of operator overloading and how it simplifies our way of writing codes for this kind of math objects, math entities, okay? And this is more natural in terms of writing the program. So let's head to Eclipse and test this. So if you recall, in the demo operator overloading project, we had this vector 2D object. And in this vector 2D objects, we already have a constructor for creating a vector 2D, okay? And we have a toString method. We overrode it from the superclass object type, and then we implemented the methods for operator overloading capability in Java, okay? Now what I'm going to do, I am going to basically right at the beginning define two constants, private static final vector 2D x hat equals new vector 2D 1 0, okay? And public static final vector 2D y hat new vector 2D 0 and 1, and let's make them double. Okay, so in the vector 2D class. Okay, now how do I use this? If I want to create a new vector, let's go to our test vector 2D class, and let's basically comment these out, and let's say I want to create this vector 1 2. What I do is I import a static from vector 2D. From vector 2D I import everything. Okay, vector 2D, from vector 2D I import all the static fields and methods. Okay, and now here I define let's say u, vector u. So vector 2D u equals 1 times x hat plus 2 times y hat. Okay, and now already recognizes x hat and y hat, and let's do a system dot out dot print line u, because we already overrode the overrode the toString method for, so this is using a constructor, and this one is using the operator overloading for writing very natural way of creating vectors using the unit basis. So using the basis vectors for the 2D space, vector space, 2D vector space. Okay, and these should result in the same thing, 1 2 1 2. Okay, and again the power is that let's say I decide to multiply this vector by some number u. Let's say I decide to add 1 to both components and then divide it by 2. It has no problem calculating that. So this makes writing our math algebra for vectors very intuitive and very human-like. You don't need to use the methods and do the old way of doing these kind of calculations on objects. So operator overloading is very powerful when we're dealing with math objects. And to remind you again, you don't need to implement all the math operators for your object. For example, for vectors, we said that dividing vector by another vector doesn't make sense mathematically. Therefore, I cannot write something like v divided by v2, because when I do this, a small v, the compiler complains, and what it complains is that operator division is undefined for the argument types demo operator overloading dot vector 2D. Okay, so it doesn't know how to interpret division of one vector 2D divided by other vector 2D. Now I can go back and actually implement the division vector 2D divide, has to be small. Okay, and here what I'm going to say, divide by some vector 2D v. Let's say I want to define a define the behavior of division to be component wise. So basically the result should be this dot x divided v dot x, this dot y divided v dot y. That's one way of defining component wise, right? So I can return a new vector 2D, this dot x divided v dot x, this dot y divided v dot y. Okay, so I'm implementing the behavior of division operator for when it acts on two vectors. and you see the error is gone now, and u and v are the same, so the result of the division should be 1 1. Let's check it. 1 1. Okay, u divided by v using operator overloading. So this is another concept. So you can define the behavior exactly the way you want it to. And I want to also show you one more thing here to understand what's going on. Let's comment this, let's comment this, and we did this in another video to look at the bytecode. Let's do it one more time to see exactly what happens behind the scenes. So show view, bytecode, and we have one line of code here, one line of code here, and basically that's it, and the code returns. So here we have two objects, x hat, y hat, so it first has to load them. So on line 26 we have a static field, get a static. It's a vector 2D and the field name is x hat, and the type of the x hat, the static field, is vector 2D. And then it loads the double number 1. So it loads this one, loads this one, 1, and then invoke virtual. Remember, when you have plus, the first expression on the expression on the left is evaluated, and then the expression on the right, and then both the results are added together, right? So it first loads this static object, and then this loads this or pushes this number 1 to the stack, and then invokes virtual. And what is it doing? So this multiplication is overloaded for the vector 2D. So it calls the vector invoke virtual, a method from x hat, vector 2D. But what is it? So remember, we had two methods. One was multiplication, and one was reverse multiplication. So which one do you think is going to be invoked? Is it vector 2D dot multiply or multiply reverse? Let's double check. You see, multiply reverse is invoked, okay? And this happens when your object is on the right side of a multiplication. So if I write x hat times 1, it invokes the multiply. If I write, let's check it. So if I write x hat dot 1, it invokes a method, and it's multiply, which the input parameter is a double, and the output or the return type is a vector 2D. Now if I put the number on the other side, so the number comes first, the object comes second, then it invokes multiply reverse, okay? So basically the idea is that if I implement the method multiply, but I don't implement the reverse, then what happens here is that yeah, because this comes from I cannot comment it out all the way, so I don't know, let's comment the maybe let's just return null. So I have implemented the multiply, and this is basically this times number times v, and then multiply reverse is v times this. Now here it returns the correct type, here it returns null. So if we do this, we should run into the null pointer exception. Let's see. Yeah, null pointer exception. But if I do it this way, we should have no problem, because it's still because of the second one that happens. Yeah, we get the okay. So let's head back and uncomment this. So this is another example of why we are doing both operation and reverse operation, because the definition is different. So when we say multiply or subtract, basically our current object is the on the left side of the operation, and the input to this method is on the right side. But when the compiler sees an expression such as v minus the vector, then it invokes this basically this method, the reverse, subtract reverse or multiply reverse. Okay, so you have to be careful and make sure you implement both of them. Otherwise, at some point your code will break depending on how you write these mathematical expressions. Okay, so here for both x hat and y hat, it has to invoke the multiply reverse. The input is double and the return type is vector 2D. So first of all, it evaluates the expression on the left, and then it evaluates the expression on the right. So after invoking this method, it again loads a static, which is y hat, okay, and then pushes this number constant double 2 into the stack, and then invokes a method to evaluate this part. So what method is it? It's the multiply reverse on the y hat, okay? And then finally, now it calculates this side, and these are both objects. So what should it do? It should invoke another method or call another method, which is add. So invoke virtual calls another method, which is add from vector 2D, and the input is a vector 2D, and the return type is also vector 2D. Okay, now what happens here? So let's say it evaluates u, and u is stored in 1. Okay, now what happens here in this line? So it has to first load the out, which is a static field. That's why it has this get a static system.out, and then the type is print stream, and then basically it creates a new string builder. So we are concatenating strings, okay? And in Eclipse, the Eclipse compiler behind the scenes, for more efficiency, it doesn't use the string class, it uses a string builder. So concatenating strings in Eclipse is efficient because it just calls the string builder, it doesn't call the string object, okay? And then basically it puts some variable into the stack, which is this I assume it's u or something, and then puts this string into the string pool, and then invoke a special is basically invoking the constructor of what? A string builder. So basically it pushes this into the stack, and then it creates a string builder, and then loads an object reference. What was the object reference? U. So loads u, and then loads the number 1, and invoke virtual. What is this? So it loads this, and this is an object, vector 2D, and this is a number. So then it has to go and invoke the add method from the vector 2D to be able to evaluate this. Notice it has to load the add, not add reverse. So it's add. So if I write 1 plus u, it invokes add reverse. Okay, so it does this, and then loads the number 2 into the stack, and then calls the division, I assume, right? Yeah, and it's not a reverse division, it's division into the, and returns a vector 2D object, and then calls the append method in the string builder that was created behind the scenes, okay, from the Java lang string builder, and then it loads, I assume it loads this string, so it appends them. Yeah, so it appends them, and then appends these two methods, okay? Evaluate this one, this side, appends them, and then calls the toString method on the string builder, and then calls the print line on the print stream object, which is out, okay? So in case you're wondering, concatenating strings in Java by default uses a string, but in Eclipse it uses a string builder. So the Eclipse compiler is more efficient in terms of the fact that it uses a string builder behind the scenes, not a string. Okay. All right, I think that's enough for this video. So again, you can go back and review the topics that we covered for operator overloading. There is one more topic that I will discuss about operator overloading, and that's basically creating a symbolic function space, because right now we have operator overloading. So exactly the way we did it with unit vectors and creating a vector space, we can have the type of these objects could be functions. Okay, and then if we overload the plus, times, and all the operators for functions, then we have no problem calculating symbolic functions. Okay, doing symbolic mathematics with objects in Java, and that will be fun. So please do follow me, and please share and subscribe, and I'll see you next time.